I'd like to thank you for your time today. My name is Kevin Holmes. I'm a senior solution architect with Red Hat, and today we're going to be looking at Ansible. There are a couple of different things when you hear the word Ansible, and we're going to define the specific pieces just to have a better understanding for this. So first and foremost, Ansible is a powerful automation engine. When we talk about Ansible, we think of YAML-based playbooks and a way to automate systems agentlessly. In addition to this, Ansible Tower is the enterprise framework that sits on top of that. Ansible Tower is so much more than just a GUI to leverage Ansible at the engine. Ansible Tower actually includes a RESTful API. I like to think of it as Ansible Tower sitting on top of a RESTful API, which sits on top of Ansible engine itself. So from the ground up, you've got the power of Ansible, the same Ansible that you'll be using on the command line, but with a RESTful API built into it, and then a GUI that can leverage all those functions. Ansible Tower adds some more enterprise-y type of features that are necessary once you get beyond a single user environment. If you're trying to share out playbooks or share out responsibilities, pass along an audit trail, or manage credentials in a way that's going to be necessary in an enterprise environment, this is where Ansible Tower comes in. But we're going to start out talking about Ansible engine as the basis of Ansible automation. Anything advanced that we do with Ansible starts off with the simple Ansible playbook. So from the start, Ansible's mantra has been simple, powerful, agentless. And let's talk through these points and understand why these are key advantages to Ansible. From the standpoint of simplicity, I've worked with a lot of IT ops and DevOps teams where they simply didn't have the time or the manpower or the energy to learn a new proprietary automation system, a new scripting language, or to be able to go and learn Ruby or Python just to be able to manage their systems. So from the standpoint of simplicity, anyone can pretty much pick up an Ansible playbook, look through the YAML, understand what's going on, or write new YAML based on the docs.ansible.com pages. It's very simple to get started with Ansible. Tasks are executed in order, so it saves a lot of the troubleshooting, bouncing around, trying to figure out where your errors are, because everything happens sequentially inside an Ansible playbook. From the standpoint of powerful, Ansible itself is not a CI/CD tool. It is not a network management tool. It is not an OS system deployment tool. It is quite simply a powerful automation engine. However, there are use cases for all of these within Ansible, and it's important to understand Ansible at its core is a powerful automation engine. I've seen use cases where people want to reach out and to see if a service is running on a server and then report back on that and take some actions based on that to automate that process through Ansible, essentially rebuilding the concept of a Nagios server. This is what Nagios is good at. This is what Nagios is for. But yes, you can do those type of things within Ansible. It is incredibly powerful outside its core use cases. And Ansible is an incredibly powerful automation engine that's capable of being a key component of network infrastructure automation, a CI/CD pipeline of OS management and system management. And much of this is possible because of the agentless nature of Ansible. For instance, no network engineer is going to allow you to install an agent on their core switches. It's just not going to happen. But being agentless gives us a lot of flexibility, and for a number of reasons. For instance, we're not trying to be cryptographers. We're not writing some new encryption algorithm to put on a proprietary agent. We're leveraging existing known trusted connection methods. OpenSSH for Linux and Unix variants, WinRM for Windows. We're not reinventing the wheel. We're taking the wheel that's already there and building a more efficient engine on top of it. So this is a grid that shows really the components on how it works, and I'll talk through these. It's not nearly as complex as it may seem here. We talked about the Ansible playbooks. We're going to look at one in the next slide here. They're written in YAML, simple markup language. Tasks are executed sequentially. So this is unlike a script where I might have an error in my script that line 32 calls an error out. So I look at line 32 of the script, it's calling a sub-function or a subroutine somewhere in line 165. And I go to line 165 and I'm banging my head against the keyboard trying to figure out what it is, and turns out it's a semicolon at line 164, and the error was really just something simple and wild, but incredibly difficult to track down. And Ansible does not have that issue because things are executed sequentially. As you run through a playbook, you can see in real-time output, the logging shows when something succeeds, when something fails, at what point that happened, and it's incredibly easy to troubleshoot for that reason. This is where The pieces behind the scenes handle the heavy lifting. I talked about the idea of trying to script things. A script does exactly what you tell it to do. Ansible sets a configuration in the necessary state. And the reason I split hairs on this, the reason that this is so different, the modules are what do the work behind the scenes. When I have a script, let's say I write a quick little 3-line script to manage some tasks on a particular server. And then I run it on server number 2, and it succeeds on 1 but fails on number 2. And so then I go in and troubleshoot, and I say, well, let me take this out of Bash and turn this into a real scripting language like Perl, and start manipulating variables, and then I'm going to have some error handling, and I'm going to start building in some condition evaluation, and maybe it shouldn't install in this way or install in this way, and then in order to make this portable, I start sort of building little include files or little local modules that can be included into this, and it really turns into a maintenance headache, because what I'm doing is reinventing not only the wheel but half of the car. And the modules for Ansible are built in, they come with. So when I say I want X, Y, and Z to happen on a system, Ansible triggers the module that says, does this need to happen? Or should I just pass this by and say it's already in this condition? Mark it as good and move on. Does it need to happen? Can it happen? What's going to be the repercussion if this happens? There are all sorts of pieces that Ansible modules evaluate behind the scenes, and I don't have to do the programming on these. I simply have to say, here's the state that I want my system to be in, and Ansible will see to it that that is executed at the end. If I'm moving a file or changing a configuration and Ansible has already applied that configuration on the system, it doesn't touch the file. It knows that nothing needs to happen and will continue to move on. So instead of the idea of running a script when you need something to happen, this is the idea of an idempotent Ansible playbook, right? At the end of the playbook, everything should be in the same state, and if you run it a second time, nothing should need to happen. So you can effectively run a playbook over and over without the concern of breaking anything, the way that a script does hard and fast rules and hard and fast actions every time you run it. We give it the concept of an inventory. For command line sense, we have a INI file type of format here, bracketed groups of systems that we use. We're going to look at Ansible Tower and dynamic inventories in a second here. We also have dynamic scripts, and this is what, with Ansible Tower, you can go through the administration panel and configure these dynamic scripts, or these dynamic inventories, so that you can reach out to your EC2 instances and pull in a dynamic list, so you don't really have to maintain your managed nodes manually. So this is an Ansible playbook, and like I mentioned, this is really fairly simple. I'm going to walk through the components of this, and it really should make sense almost immediately. Right? We have these name fields, and these essentially help with logging. They really serve two purposes, in my opinion. First of all, when you launch this Ansible playbook, you can see this text coming by in real time, so that when we get to the install HTTPD, we can see what's happening, and we recognize in the logging that event is happening in that actual order, and it's very simple to understand. Without that, this would simply just say yum success, right? So we can put some pretty text here and understand what's going on as a result of that. The second purpose that I think these serve, and this is probably on a larger scale more important, this is the documentation. So this Ansible playbook does not require a second set of instructions and explanations on what it's doing. The name fields act as the documentation for this Ansible playbook. So you can look through here and pretty much see what's happening at any given moment all the way through this playbook. We give it a definition of hosts. These are the hosts that we're going to launch this against. In this case, it says all. This could be a dynamic subset. This is actually really easy to do within Ansible Tower. We narrow this down to dynamic groups. Ansible Tower gives us the ability to really take a granular control over the host we want to launch this against. In this case, we're passing a number of variables, well, 2, but 2 is a number. We're giving this the HTTP port and max clients. Now, we can't see really what this template file looks like, but down here, third line from the bottom, we have this Jinja2 syntax template file. These particular variables are in that file in double braces. So curly brackets around a variable name, and the template module effectively does a string replace, and we'll use those. There's a order of variable precedence, so we can actually replace these conditionally. We can evaluate, does this system have 4 CPUs? If that's the case, we're going to go max clients equals 210. There are a number of things we can do by taking these variables and making them flexible, yet making the playbook launch and run the same way every time it runs. We give it a user for credential purposes. Now, it's sort of a misnomer that Ansible has to run as root. It doesn't. Ansible just has to launch with credentials that can perform the actions that need to be taken. So if we're dropping a tiny little text file in the temp directory, you don't really need to have any particular special permissions for that. But if we're going to be installing software, we have to have administrative privileges of some sort. And that's the same with agent-based solutions. That's the same with logging in as a normal user and performing these actions manually, right? It's really goes back to our system security. There are a number of ways now to handle privilege escalation, service accounts, and we can do this in a number of manners that are going to still be friendly and acceptable to auditors, PCI, FDIC, SOX compliance, right? Government can use this. There are ways to set this up to have the actual user launching these credentials still link back to a real human account, so that auditors are still satisfied with this. So that sometimes concerns people, but it really isn't a problem. It's extremely doable. Here we have a list of the modules, and this is really the last piece, and then we're going to take a look at how this integrates into Ansible Tower. So to the left of the colon, we have the name of the module. To the right of the colon are the additional parameters we're passing in. So the yum module, for instance, as you might expect, this is related to the yum command or the package installation for Linux. We're not saying install HTTPD. We're saying Ansible, regarding this yum package, regarding package HTTPD, I want the state to be the latest version of this. Now, this state has a number of different parameters, and these are all listed, well documented on docs.ansible.com, all the different parameters. We could have state equals present, which means Ansible just evaluates, is this installed? I really don't need to update it if it is even there. State equals absent. I've seen situations where people will put a piece of nasty software packages that they do not want installed, compilers, X Windows, and you can loop through and just say state equals absent. Make sure that those are uninstalled or remain uninstalled. But in this case, we have HTTPD, and we want to make sure that it's installed. So we're saying state equals latest. We have a template file with the curly brackets from max ports, from HTTP port and max clients, and it's going to end up in this particular path. And at that point, it's going to be changed. Ansible's going to recognize I have variables. This is calling for variables. I'm going to write this file in such a way that those variables are transferred into that file. Now here's the thing. If this file already exists, because of the idempotent nature of Ansible, it does not need to touch that file. Ansible will first evaluate, hey, I'm about to write a file. It's going to include these variables. If this file is literally going to look exactly like the one that's already on the system, I'm not going to touch it. So your modified time stays the same. Nothing was changed, and Ansible will just go through and report everything's within config. There's been no drift. And then lastly, we are going to manage this service. We want HTTPD to be running at the end of this. So quite simply, if it's not running, this will start it up. If it was already running, this will allow it to continue to run. And there are a number of different states. We can have restarted, stopped, reload. There are different ways to manage these pieces depending on what our playbook needs. But in this case, quite simply, we're making sure that HTTPD is installed, that this template file for the config looks like we need it to, and that we're running at the end of the playbook. All these things, like I mentioned, in the documentation. One of the things I can't say enough is the documentation for Ansible is phenomenal. Every module has verbose documentation as well as copy-paste examples for how to use each Ansible module at the bottom of the documentation. Right now, we're shipping with right around 1,500 modules. So it's highly unlikely you'll stumble across a function that you can't do right out of the box. If you do decide you need to write your own module, PowerShell for Windows, Python for Linux modules, and it's not terribly difficult to write your own modules if you choose to do that. You don't need to. Most people never need to, never will, but it's capable, as is the nature of open source software, and we even have documentation on our site exactly how to do it, how to manage what comes in, what goes out, and what happens in between. So that's always a possibility for extensibility there. Now what I'd like to do is take a look at Ansible Tower. Once again, Ansible Tower is not just a GUI on top of Ansible. There's a RESTful API that's fully functional in between. So anything that can be leveraged within the RESTful API can be leveraged So anything that can be leveraged within the Ansible GUI can also be leveraged through a call to the RESTful API. This gives us a number of possibilities when it comes to automating through extensibility from other third-party applications, having a Jenkins job trigger an Ansible playbook to launch, passing extra variables to it so that it knows what systems or what artifact or what version number we're talking about. And once again, Ansible Tower really adds that enterprisey sort of feature set that you can't get from simply sharing an SSH connection amongst users on the command line. Features such as aggregated logging or passing your logs to a SIEM or a third-party auditing service. Keeping track of user logins through role-based access control or managing the visibility from one user to the other, allowing credentials to be shared without them being visible from one user to another. From a security and scalability standpoint, Ansible Tower handles this wonderfully. What I like to do is start with what we call a job template. And you can think of this as a template or a definition of a job definition, if you will. This is where all of the components of Ansible come together in Ansible Tower. We turn this into a job that we can either launch through a push-button launch, through a predefined schedule, through a RESTful API call extensible from another application. It's extremely flexible once we define the job here. So let's pop through these fields and just talk about what they mean and help to understand what a job template encompasses. We have new server standards here. This is just a pretty name that we use for our record keeping, for keeping sanity amongst our playbooks. Have a description here if we wanted to give it a further description beyond that. We have the option to run or to do a dry run. And here we're using a dynamic inventory that's called VMware in this case. We're going to talk about dynamic inventories in just a moment. So we'll break that out into an additional tab. We also have the ability to limit this based on a group called LAMP, and we're going to see that group inside our Ansible Tower inventory, our dynamic inventory. That group is actually a set of tags in our VMware vSphere environment, and we're limiting to a group called LAMP that is quite simply a set of LAMP servers that we've defined in VMware. We give the option of verbosity for the sake of what we're doing. Normal set of verbosity is great. Ansible Tower also allows us to extend out to instance groups. This is where scalability into other networks, into other environments may be required. Think of it as this way. You've got a DMZ network or a private network, maybe an AWS EC2 VPC, where you can't just regularly SSH and connect into these machines. But an instance group in that location allows you to channel that traffic to manage that remote workload through a tower instance. Down here, some additional options for privilege escalation if we need this to run as a privileged user. We have a number of different options for that type of privilege escalation, but sudo's the default. Here we have an option called provisioning callbacks. This gives us the option to open up a provisioning callback URL, and it's well documented right here. This gives us a URL that can be called from a remote system. So let's say a use case for this might be you build a brand new system either through Vagrant or through a VMware template or through a bare metal Pixie Boot kickstart. And when that system is up and running and has the bare OS that it needs in order to talk to Ansible, it can run this curl command and it acts as an API call. Ansible Tower hears that provisioning callback and will say, I'm going to go ahead and lay down this job template on you because that's what you want. So it's a way that managed systems can reach out to Ansible and request to be provisioned through this provisioning callback. We have the ability to pass along extra variables here. We even have the ability to add a job survey. So let's say we want to add some extra variables in and force the prompting of these every time this runs. So we want to ask for a change ID, and we're going to give that a value, variable name change ID. And we're just going to allow that to be a text field. And then let's say we also want to have an additional arbitrary variable. What's your favorite flavor of pie? Why not? And what we're doing here is we're passing this input along to something that Ansible can manage. So we're going to go chocolate, pumpkin, apple. And the default answer will be apple if nobody responds to anything else. Once we've added these, we can actually edit these again. The default answer, I don't have a change ID. We can update that survey. So what this does is when we run this particular job template, the first thing we're prompted with is this survey. What's your change ID? We can change this to an actual change ID number. And let's be honest, pumpkin pie is better than apple. Now when we launch this job template, we see in additional variables here, these fields have been captured and utilized in the playbook. From an auditing perspective, we can always go back and see what inventory was used, what additional variables were passed, who the real user was that logged in. In this case, it's me using the admin account, but this would be you with your Active Directory account, most likely. We see the playbooks, and we see the machine credential that was used. So from an auditing perspective, we have all the information we need to capture here, as well as the actual commit to the project's playbooks. We could go back and reassemble exactly what happened. From an auditing perspective, we've captured who did what, when, with what extra variables, and under what conditions. So we talked about dynamic inventories. Let's take a look in here into the inventory that I have called AWS, for instance. In here I have a source that utilizes my credentials for my Amazon EC2 inventory. And when I synchronize that, it comes back with a number of EC2 hosts. We see that it also groups them based on a number of parameters that I've defined. So in this case, we have the type of machine, we have arbitrary tags. This one is tagged purpose node. This one's tagged tower demo. And so throughout these groups, we could actually say, I want to go with something that has the purpose of node that we've given this arbitrary tag, and filter, limit just on these three. So we can use this inventory, but limit it down to systems with this particular tag there. This gives us a lot of flexibility because the dynamic inventory automatically captures those fields. And those fields are dependent on the particular inventory type. If we go into a satellite server inventory, with here the sources, we have a satellite server. And when we look at the hosts that satellite is pulling down and the actual groups that it pulls in, we have different life cycles, we have host groups, location and organization are a couple of the standard fields from satellite server. So we can actually have a particular Ansible job template launch against just a specific host group or a specific lifecycle environment. In this case, we have library, we have different levels of content. So, and all of this will make sense when you see this in terms of your satellite environment and the fields and the host groups that you're using. But these groups are created automatically. So once again, this particular inventory script does a great job of reaching out to the Ansible, to the satellite server and pulling in an Ansible inventory with these hosts in a way that we can utilize this and group them and limit them based on those hosts. One other thing I want to talk about is a workflow template. So this is the next step once you have a job template. Now, as you'll see, these are all labeled as the same job template because it was a lot simpler to just take the one that I've used for this demo and clone it. But what we have here is a blue line indicates an event that will always happen, and a red line indicates a job template that will launch on a failure of the prior step. Green line will launch on the success of the prior step. So let's say we go to this step here and say, I want to add another step after this. It's going to be this guy, and we're going to say this happens on success of this first step. And then we can add another one, and if this particular one fails, we want to run this on failure. So we have sort of a choose your own adventure series right here where we can build out almost an orchestration workflow of step by step. And each of these is its own independent job template. Now, where this gets really cool is each of these job templates might be owned by a different user with a completely different set of parameters that aren't visible to other users. So you can now have an IT ops division and a networking division and a dev division all working together on components that can end up in one giant orchestration template. So this workflow template can contain components of other users that really can't see each other's work. So when you think of Ansible as a collaboration tool, once everybody gets on the same page, it's very easy to pass job templates from one to the next and make everything happen in a pretty logical, simple, automated workflow. I also want to touch on credentials because this is a very important topic. So we have a particular machine credential here, and I can't say this strongly enough. Once I've entered my SSH private key or my password, now I am the root user and the system administrator on this machine. This is my box, and I'm not able to recover those passwords in a plain text format. Once I save those into the Ansible Tower interface, they're saved in a one-way encrypted hash, AES-256, in such a way that Ansible Tower can leverage those credentials, but I cannot retrieve them. So no matter what access I have on this box, I'm never going to see my password in plain text. I'm never going to see the SSH private key in plain text once I've submitted that. I cannot recover that in a visible, shareable, plain text way. However, I can give permissions to this object because everything is a role-based access control object. So I can give permissions to other users on this machine and tell them that they have the ability to change this or update this password or to use it in their job templates. The same goes with inventories. If I have a particular inventory, let's say I don't want my VMware inventory to be used or visible to anybody else, or let's say that by organization it's not visible and I want to explicitly make it visible. I can add permissions to this object and give other users permissions to view, utilize, manipulate any level of this object to use that in their job templates on this tower. So what we end up with is we end up with an Ansible Tower environment where everyone can coexist. We have IT operations and networking and dev and DevOps all sharing the same Ansible Tower without stepping on each other's toes and overriding each other's settings. So with Ansible Tower, we have the capability to add on top of our simple, powerful agent list to give control over those jobs, to have the knowledge and visibility for compliance on what's happening with those, and the delegation and sharing, but only within the parameters that we provide. So we can allow sharing, but we still have the control over that. It's not just wide open. And this only scratches the surface of Ansible and Ansible Tower. There is so much more to see. Take a look at these links and take a look at docs.ansible.com. We've got all the information to get you started automating and up and running quickly. Go, go.